Okay, we are going to do ionic bonds and drawing the ionic bonds and compounds and coming up with the formula for these compounds. So, to start off with, what is an ionic bond? It is a bond between a metal and a nonmetal. It involves the transfer of electrons from the metal to the nonmetal, and it involves the attraction of these opposite charges that are formed. So we've already discussed ions and how ions are formed from the gaining or losing of electrons. Metals lose electrons and become cations, which are the positive ions, and nonmetals gain electrons and become anions, which are negatively charged ions. Okay, so with all of that information, let's look at our periodic table. A little review. I have highlighted the metalloids for you in pink. Okay, everything to the left of the metalloids are your metals. Okay, so everything to the left. The only exception is hydrogen. It is not a metal. And then everything to the right are your nonmetals. Okay, that's all of these in this corner over here above the metalloids. Okay, so just remember, metals are to the left, nonmetals are to the right of your metalloids. All right, so all of our ionic compounds are going to be made up of one element from the right side of the periodic table and one from the left side of the periodic table, or actually the left side and the right side of the metalloids. Okay, so let's pick a metal and a nonmetal to start us off with. So let's start simple. Lithium and fluorine. Okay, I have written above all of the group numbers. So there's groups 1 through 18. They're the columns. Okay, we can figure out the valence electrons based on what group they're in. Remember, everything in group 1, that's this group, has 1 valence electron. Everything in group 2 has 2 valence electrons. We skipped the transition metals. We don't count them. Okay, we don't know how many they have. We'll get to those later. Group 13 has 3 valence electrons. Group 14 has 4, all the way to group 18, which has 8 valence electrons except for helium. We've discussed helium only has 2. Okay, so lithium is in group 1 and it has 1 valence electron, and fluorine is in group 17. It has 7 valence electrons. So we're going to start off by drawing the dot diagram of lithium and the dot diagram of fluorine. Okay. Based on our knowledge of ion formation, we know lithium as a metal is going to lose electrons and fluorine is going to gain electrons. So basically this electron jumps over to fluorine. Now we don't draw this with arrows, we just draw the dot onto fluorine. Okay, that represents that electron. And lithium, since it lost an electron, we subtracted a -1. Okay, that means it's going to become a +1. So we will put a positive charge on that lithium. And fluorine gained 1 electron, so we added a -1, which overall is a -1 charge. So fluorine's going to have brackets around it since it has all those dots with the negative sign on the outside. Okay, lithium gave up all of its electrons. Fluorine has all of the electrons at once. So there's only an Li and an F involved. 1 lithium, 1 fluorine. So its formula is LiF. Okay, let's pick 2 more. Let's do magnesium and sulfur. Magnesium and sulfur. So Mg, okay, we see magnesium is in group 2, so it has 2 valence electrons. Sulfur is in group 16, so it's going to have 6 valence electrons. So magnesium has 2 dots. And sulfur, I'm going to do them in the same color since y'all will be working with pencils. And you can see, has 6. Okay, so magnesium is the metal, and it's going to want to give its electrons to sulfur, the nonmetal, and magnesium will become the cation, which is the positive ion, and sulfur will become the anion, which is the negative ion. Since magnesium has 2 to give, and sulfur only needs 2, those 2 are just going to hop over to sulfur. And to show that they came from magnesium and they went to sulfur, magnesium's charge will be put on it, and sulfur's charge will be put on it. Now, the reason it's +2 and -2, remember, magnesium, we subtracted 2 electrons, which add up to a -2. So when you subtract a -2, you get +2. For sulfur, we added -2 to it. So when you add a negative, you get a negative. So that's where those charges come from. Okay. And since both are satisfied, magnesium has lost all of its electrons and sulfur has gained all that it can. It only took 1 magnesium atom and 1 sulfur atom to complete this compound. So the formula for this compound is MgS. All right, 2 more. Let's do sodium and oxygen. Okay, sodium is in group 1, so it has 1 valence electron. Oxygen is in group 16. It has 6 valence electrons. So Na has 1 dot. And what do we say? Oxygen, sorry. Oxygen has 6 valence electrons. Okay, so sodium has 1 to give, and oxygen wants 2 to be happy. All right, so sodium's going to give this 1 to oxygen. Okay, now sodium's satisfied. It's gotten rid of its 1 electron, and the fact that it got rid of an electron gives it a +1 charge because it only got rid of 1. But oxygen still has a spot for an electron. It's not necessarily happy yet. So we have to get another electron from another sodium. Okay, so another sodium has to be involved in this compound to give its electron to oxygen. Okay, and that sodium gets a +1 charge, and oxygen gained 2 electrons, so it gained 2 negatives, so it gets a -2 charge. Okay, again, you can check your signs by whether it's a metal or non-metal. Metals always become positive, non-metals always become negative. The overall charge, so these 2 sodiums with +1 charge total a +2, and then this oxygen is -2. So the overall charge of this entire compound is a net charge of 0. So -2 + 2, and that they cancel each other out. Now the formula for this compound is going to be Na2O. It took 2 sodiums and 1 oxygen to create this compound. All right, one more. Let's do aluminum and sulfur. Okay, aluminum was in group 3. So it has 3 valence electrons, and sulfur is in group 6. So it has 6 valence electrons. Oop, I went one too many. Okay, so aluminum, the metal, is going to give its electrons to sulfur. It has 3 to give. Sulfur only needs 2. So only 2 can hop over to sulfur. And this sulfur becomes a -2 because we added 2 electrons to it. But aluminum still has an electron to give. So another sulfur will have to be pulled into this compound. Okay, and this sulfur wants 2. It gets 1 from that aluminum. So now the aluminum's gotten rid of all of its valence electrons. It's 3 valence electrons, so it gets a +3 charge. But the sulfur still needs another electron. So we have to have another aluminum that can give one of its electrons to this sulfur. Okay, now this sulfur is satisfied with its octet and it becomes a -2. But we still have aluminum with its 2 electrons it wants to get rid of. So we need to add another sulfur. And this sulfur wants 2, and conveniently this aluminum has 2 to give. So once we transfer those electrons, then we're done. Everybody's happy. So when you add up the charges, so 2 plus 3s is a +6. 3 -2s is a -6. So this is an overall 0 or neutral compound. Okay, the formula for this is Al2S3. You had 2 aluminums and 3 sulfurs. Okay, so when you make these compounds, just know that there are more than one atom sitting around when this is creating its bonds. So you have, way more than one. We'll get into a mole and Avogadro's number later, but just know that these atoms are so small, they're not going to be found by themselves. So in order for this actual compound to form, you would have to have 2 of them bond with 3 sulfurs, but a lot of them will bond at the same time. For sodium and oxygen, you'd have to have 2 sodium atoms and 1 oxygen atom. And for magnesium and sulfur, 1 of each, and lithium and fluorine, 1 of each.